this one. Yeah, let me just draw the functions. Basically, they're going to have some different functions, and you do get a 3x5 card. You can use on both parts, right? So I'm not into memorizing all kinds of things, but really understanding. That's math science, is understanding how to do things. So you can put all these on a 3x5 card. Let me just show them to you right now. So U shape, you guys know that one. What does that one look like? Y equals x squared, right? I don't even know what it's called. I guess it's called the square function. I'm not into the names as much. Yeah, so it's a square function. And then let me draw the other ones. What is?
There's like 6 or 7 of these.
Yeah, I know. Yeah, I know. So I'm just going to set them all up right now and then just say the rest are the same. I'm just going to tell you all of them right now. What's y equals the square root of x look like? Anybody know that one?
Goes with the curved line.
Goes like that. Yeah. Shoots off to the right like that. Like good. I always think of it like a firework because it looks like you set a firework on the ground and it shoots it off to the right. So it stops. That's the only graph that stops at square root of x. Okay, let's do some more. What does x to the third power look like?
Sideways and
It's a vertical snake, like that. And then what is cube root of x? See how I'm doing second power, second root, third power, third root. What does the third root do? Yeah, it turns the snake sideways. Yeah, it's flatter. That's right. Like that. And then absolute value. You guys know what absolute value? There's 6. We're going to memorize here or put on your 3x5 card 6 of them. What does the absolute value of x look like? Yeah, it's a big V. So it's not a U, it's straight lines, 2 straight lines in a V graph. And finally, the weirdest one of all, y equals 1 over x. Anybody know what 1 over x looks like? Yeah, a couple of diagonal branches. In fact, it has asymptote lines. We'll talk more about those later. Let me just put them in for now. Asymptotes are diagonal lines that a graph gets real close to, right? So anyway, it's a branch here and a branch there. Diagonal branches, that's 1 over x. Right there. So there's the big 6. We'll use those all semester long. We'll learn to do all kinds of fancy things with those big 6. All right, so which one's this? Well, obviously it's the U shape, it's the square function. There it is. So they're just going to practice identification with these first few questions like that. Good so far? All right, so have those big 6 on your 3x5 card. In 2 sections, which is going to be Wednesday of this week, day after tomorrow, we'll spend a lot of time talking about those big 6 and how to move them up and sideways and how to flip them and stretch them and compress them, and we'll learn a lot about graphing. We'll start with the basic 6 and then do all kinds of manipulations to them. Very important section. A lot of those questions will be on part 1 of the exam, as they just started with a line. So, okay, f of x. F is just y, as you know. So that's just y equals 3x. That's just a straight line. I didn't even put that. I don't even think of that as one of the big 6. That's just a straight line. So if I want to graph a straight line, where do I start? How do you graph that equation? There's really a 0 out there, huh? Plus 0, you start at 0, which is the origin. What's the 3 do? 3 over 1, rise over run. You know all this from your algebra days. Up 3, over 1. So up 1, 2, 3, over 1. There's the other dot, connect the dots. So whichever graph that is. D, yeah. Be multiple choice on the real exam as well. Just like that. Good? That's easy. Graphing straight lines. Good. All right, so we got y equals minus 5x cubed. Okay, so basically it's going to be the snake graph, the vertical snake, because it's x cubed. So this is the way you should think. So we're starting, and especially Wednesday, we're really going to hopefully begin the building of your ability to graph well. That's one of the main goals of this class. We have a few main goals. That's almost the biggest, maybe the biggest. I don't know exactly off the top of my head, but that's certainly one of the main ones, is that by the time we're done with pre-calculus and you're ready to move on into Calc 1, if that's where you're going, that you're pretty comfortable with graphs, meaning you can look at an equation and have a general idea of what that graph looks like. It's really helpful. It's really helpful. I just had a gal grab me over the summer, and she said she was in Calc, and she was using all the stuff she'd learned in my pre-calc about graphing, and it was really helping her out. So it's really a valuable thing to be able to just look at an equation and know, okay, and when you see it, so here's how that works. Here's how do people know? How do people in higher math classes know all kinds of graphs. Well, they do it this way. They memorize the big six. They just know those cold. And then they learn what makes graphs flip or move or compress or stretch. They learn those basic operations. So that's our plan. This book does a great job on that. That's why it's one of the main things I like about this book. So you look at x cubed and you should think the following thought. Okay, that's basically this, but they've done something to it. So there's the basic x cubed graph, the third power snake, the vertical snake that goes up and down. Now, what is that minus 5 going to do to it? Well, I know you haven't learned everything about all that yet. Question, comment?
It flips it.
It turns out it does flip it. Yeah, you don't need to know it for this section right now. We'll get into it later. I'll just say it for right now. Yeah, it's a flip, but that's not saying enough. There's two ways you can flip. You can flip sideways or you can flip vertical. Which one is that? Well, it turns out that that's a vertical flip. The reason is it's because it's not in there with x. If it was like that, then it would be in x's little world, and then it's an x kind of thing, meaning a right-left kind of thing, a flip, sideways, x. But it's not. The minus 5 is separate from the x. I know you look at it and think, well, it's right next to the x. Yeah, but it's not in x's little world. It's not in the cube world. Right? What's x's world? X is being cubed. The negative 5 is not in there with him. So it's really not an x thing. So again, you don't need to know all this right now. I'll get into it real seriously Wednesday, but I guess it would help if I just kind of mention it now to kind of get the idea in your mind. The way you look at a number that's on an equation and you're the first thing you should think, that negative 5, you should think, is that negative 5 going to do like a vertical thing, or is it going to be a sideways thing? That's the first thing you want to get straight. Is it going to do an up-down kind of thing, or is it going to do a sideways thing? And then within that, there's different things you can do, up, down, or sideways. You can pull up, down, or compress up, down, or you can slide up, down, or you can flip up, down, and all those same things for sideways. So the first fundamental thing, is that an up-down thing or a sideways thing? That's an up-down thing. Why? Because he's not in x's world. That's how you distinguish. If the number or the whatever is right in there, like they say, you want to, if you have compassion for somebody, you enter into their world, you feel what they feel. Maybe that works for the little math, kind of touchy-feely math there. But that'll work, right? We'll use that. So that negative 5 gets in there. If it was like that you would look at that negative 5 and go, oh, he's in there. He's feeling what X is feeling. He's an X thing. He's a sideways thing. Because the x-axis is sideways. The y-axis is up, down, right? Whereas if it's not, this guy is like, I'm not feeling what X is feeling. I'm separate from X. Then that's an up-down thing. Does that make sense? That's the fundamental rule. And that goes for any of these, not just x cubed, right? Think about absolute value of x. So if I put the 5 in there, that would be what? Is that 5 an up-down or a right-left kind of 5? Is that in X's world? Feeling what X is feeling? Yeah, so that means he's an X. He's a right-left thing. He's X. Whereas if I put it out here, like that 5 would be an up-down thing. He's not in X's world. He's not identifying with X. He's up-down. He's not X. He's up-down. He's Y. See the difference? And then beyond that, we have to talk about what they do sideways or what they do vertical, as far as stretch, compress, flip, slide, what they're doing. So we'll get into that too. So let me just take it slow, and we'll kind of mention as we go. Anyway, like I said, for now, you don't need to know all that. You just look and go, okay, it's a snake kind of graph. That minus 5 is doing something to it. Turns out it's doing a vertical thing because it's a Y effect. I call it a Y effector. It's going to do a Y kind of thing because it's not in X's world. Can hardly even read it anymore. It's a Y thing. Now, what is it? It's a times number instead of an added subtracted. So maybe I will mention the story. It's a times number. Numbers you multiply or divide instead of add subtract have compression and stretch and compression effects. So that multiplying something by 5 will stretch it 5 times as tall as it normally would. That's what that'll do. If I divided it by the negative 5, it would compress it to be 5 times. It's 1/5 the height that would normally be. Does that make sense? Multiplying, dividing. I'll write all this out later on Wednesday, but I'll just mention right now. Multiplying, dividing is stretching and compressing the graph. Whereas if it was like subtract 5, that would slide it down 5. It wouldn't stretch it or compress it at all. It would slide it down 5. Everybody see the difference? Numbers added and subtracted leave it intact but move it. Numbers multiply, divide it, stretch it, and compress it. Get the idea? So this is a multiplied negative 5. And because it's negative, it's a vertical flip. So it's going to say, grab that thing 5 times as tall and flip it vertical. That's what it's going to do. It's going to grab this graph and go, pull it up, pull it down, and flip it. Whoops, I just moved the whole screen there. So it's going to go, so it's going to basically end up like that. That's what it's going to look like. If you know all that, you can just go, it's either this one or this one. And this one looks taller. That's the one. Now, you don't have to know all that right now. I'm just going to show you by plugging in points. We'll keep it simple for now. But that's where we're going in 2 days. We want to be able to look at that thing and say it's been stretched vertically. It's been flipped because of the negative. The negative flips it. And it's tall and thin, stretched and flipped. It's A. But today, you don't need to do all that. You can just plug in some points. You can just say, look, I generally know what it is, and I'm going to help myself out by plugging in some points. So what points are we talking about? Let's plug in x is 0. And we're plugging into y equals minus 5x cubed. You plug in 0, you get 0. That's nice. Yeah, they all go through 0, 0. That didn't really help us a lot, huh? Let's plug in 1. When you plug in 1, what do you get? Minus 5 times 1 cubed. What's that? Negative 5. So that means this graph, after all my scribbling here, let me get it straight. This graph goes through 0, 0, of course. They all go through 0, 0. And over 1, down 5. Over 1, down 5, right there. So sure. And then, so that's really all you need. You know, if you know the basic shape, that it's a snake graph, you know, all you need is 2 dots. You know this is the center. So what must it do? It must go like that. Over 1, down 5. See, this is right. Over 1, down 5. So it's A. Does that make sense, how we identified the right graph?
Yep.
How we doing? Is that good? Questions I can answer? So I did a lot of talk about theory, but in the end, really, this is all you needed to do for now. For Wednesday, we'll need to be a little more advanced. So I gave you some more advanced information. But for today, all you really need to do is just plug in 0 and 1 for x. That's really all that's required. Get a couple of dots. Get these 2 dots just by plugging in 0 and 1 for x. Get the 2 dots and know it's x cubed. Know it's a snake. So draw a snake through those 2 dots. That's all you really need for now. We're just kind of getting our feet wet. We're just warming up. Wednesday, we're going to dive in the pool and really swim. But for now, that's all we need. Okay.